talked about radicals before. It's a square root. A square root's a radical. Remember we've looked at, thanks, you just put one up there. We've simplified radicals by moving back and forth with exponents. Like the square root is the same as what fractional exponent? 1/2, right? A cube root is the same as an exponent of 1/3, a fourth root, and all that. Yeah? Okay, so when we get to simplifying a radical, if I had the square root of 48 as my problem, can you guys see this, or should I just turn all this lights off? If I turn all the lights off, can you still see what you're doing? Okay. Now you can see that better. Is 48 a perfect square?
Nope.
No. So if I took the square root of 36, I would get 6. If I took the square root of 25, I would get 5. Well, the square root of 48 is not a perfect square. So, good for you guys. Do you remember how to do prime factorizations? Let's make a tree. Give me two numbers for 48. 6 and 8. Or it's not 6 and 8. Sorry, I wrote 16, not 6. I don't know why. All right, keep going. 3 and 2. 4 and 2. 2 and 2. Now, back in chapter 8, we would write our answer as 2 to the 4th times 3, right? Yeah? But we're not going to do 2 to the 4th. We're just going to do the whole string of numbers. So I'm going to write it as 2 times 2 times 2 times 2, because there's 4 of them. And then I'm left with a 3. Those are all of my prime numbers. 2, 2, 2, 2, 3. Okay. Now, I'm going to make some really smart pairs. If I pair together the first 2, what is 2 times 2? 4. So what is the square root of 4? 2. Okay, now notice. I guess I should have talked about this first. Instead of just 48, this is a square root of 48. So the square root of 48 is really the same as saying that we have the square root of 6 times the square root of 8. So the square root comes down. So the square root of 48 technically is the same as the square root of 2 times 2 times 2 times 2 times 3. Okay? But if I break them up individually and turn this into a square root of 4, what can I turn these two in? A square root of 4. Does the 3 have anybody to join with? So it just stays a square root of 3. So far, so good? What does the square root of 4 go to? 2. What does this square root of 4 go to? 2. Does the square root of 3 go anywhere? No, it stays the square root of 3. What's the operation occurring between all of these? Operation, multiply, division, multiplication, good. So since these are all being multiplied, my simplified form of the square root of 48 is going to be 2 times 2, which is 4, and I'm left with a square root of 3. Okay, if I were to type in the square root of 48 in my calculator, which I don't have on me, I'm going to get some kind of decimal. Okay, it's probably going to be, square root of 49 is 7, so it's going to be really shy of 7, so maybe 6.9342, I don't know what it is, I'm making that up. Maybe 6.8, something around there. If I were to type into my calculator 4 times the square root of 3, it's going to get me the same number. So I'm not changing the number, it's staying the same, I'm just making it look better. I'm simplifying it. Alexa.
So if we were to write that as the answer, what would we put a multiplication sign?
Well, you had just, it's 4 square roots of 3. So the square root of 48 is 4 square roots of 3. So you do not put like a dot in between there. I mean, if you did, it wouldn't be incorrect. Okay. So when we get to problems where we end up taking the square root of a non-perfect square number, like 48, you're going to need to know how to simplify your radical, because your answers are going to need to be in simplified radical form. All right, so let's try another one. Let's simplify the square root of 50. What do you want to make your two branches? 5 and 10. Okay, 5's prime, so that's done. 10 would go to 5 and 2. So now we have 5 times 5 times 2. We're looking for pairs. Why do you think I'm looking for pairs?
Because you know that.
Because it's a square root, and a square root gets you two numbers together, right? So the square root of 5 times 5 really would be the square root of 25, and I'm left with a square root of 2. So what's it going to go to? 5 square root 2 would be your simplified form. Okay. Yes, maybe so. All right, see if you can try this one on your own, 120. See if you can simplify it.
I think so.
Got this, Aiden?
Yep. So hot, dude.
We are all hot. Complaining about it does not make it more cool.
I'm always hot. I'm cool as an ice cube.
You act up.
Also.
What do you do with the extra two?
So, good question. So now I'm left with only one pairing of 2, right? So that gives me a square root of 4, and then I have a square root of 2, and then I have a square root of 3, and then I have a square root of 5. Well, the square root of 4 is going to turn into a 2. Then what am I going to do with the rest of those square roots? Not add them. What's the operation? Multiply. So 2 times 3 is 6 times 5 is 30. So my simplified form is 2 square root 30. So if you keep...
No, I thought you added them.
No, this is all multiplying. Everything's being multiplied.
Wait, redo the last step for me.
So I only have one pairing of 2. These are all the non-partnered up numbers. So all the non-partnered up numbers get multiplied together and go underneath the radical. Do you remember what we call that? What's that word? Radicand.
Just
Nice.
2 to the 3rd. No.
No. So these two combine to make a 4. Square root of 4 is 2. So it's no longer a radical anymore because it's a perfect square. So I'm trying to make as many pairings as I
What about the
can.
other 2? I don't have an extra.
That one doesn't have a pairing. You don't have an extra 2?
Oh.
You should end up with 4 extra 2s. What numbers did you do?
Oh, I did 16. Oh, I just messed. Okay, I messed it up.
All questions are answered?
Yeah.
All right.
So much sauce.
No, it's not. You're just doing your factor tree. 72. Factors for 72. What are going to be your 2 branches?
Can I do it on the iPad?
No.
Oh. 9 and 8, bro. What are the
Okay.
4 and 2? 2 and 2. I don't know what to do. Wait, no. 2 times 2 times 2 times 9.
9 is 3 and 3.
Times 3 times 3. And now 2 pairs up with 2 and 3 pairs up with 3.
So...
Oh, you're killing it, bruh.
you have 1, 2,
Killing it, bruh.
3.
Woo!
All right, hold on. So we got a pairing of 3s. The square root of 9 is what?
What's that 2 just
3.
chilling
So
there
that goes
for?
on
Below the.
outside.
What's that 2 just chilling there for?
Well, you have that. No, hold on.
So the square root of 9 is...
You got that, so it swings down
4
right here.
is the 2. So those are going to come
Because you have the 2, and you have the 3.
and you're left with...
So you got that right here. And it's just, and then you got these blocks, so they come down here, and that comes down here. And then you got that right there, that right there. So you got 3 and 2, and then you got a 2. Since you got to box that, and you got to box that, and you got to box. You don't box that, so that's alone.
Square root of 36 is 6.
So
It looks like a face. Look at that's a circle. Those are the eyes.
I have no idea what any of that says.
No, I'll show you.
I got it. 9 and 8.
That's what I put.
3 and 3. 4 and 2, 2 and 2. So we get 3 2s.
You box the 2s, you box the 3s, you have a 2 left over.
Alright, so this is a square root of 4, this is a square root of 9, and then I'm left with just a square root of 2. The square root of 4 is 2. The square root of 9 is 3. What's the operation occurring between all of these things? Multiplication. What two things will multiply together? 2 and 3 will come together to make a 6, and then you're left with that square root of 2. Okay? Alright, try this one. Do this. I'll give you an easy one. The square root of 12.
Oh, yeah. Can I try it on the pad?
No. It looked pretty bad the last time. No.
It's because I wrote too much. I know how to simplify.
You forgot the skill of zooming it in.
Yeah, that's what I forgot. So if I try it again, I won't.
Oh, what? Your boy Ada doesn't get no shine.
I got it. Oh. I got it right.
Oh, there you go.
Bro! Oh, no, wait. How do I move?
There you go.
Okay.
4 and 3. Nope, too big. 4 and 3.
What's that?
4 and 3. Do 4 and 3.
Why? Oh, but wait. I'm going to try and write it, and I'm going to be looking at that. You got to try it out.
Times 3.
I know.
Alright, try the square root.
Oh, yeah.
Wait, what did you get? 2 square root of 3. Try the square root of. Oh, yeah, 4. Okay.
Wait, what's going? What times 3?
Yeah, check it. Hey. Hey, check it. Hey.
Square root of 24.
No. Oh, 24? Okay.
Is that right?
Oh, wait. Next page.
Yeah.
No.
Just use the. Looks like a windshield wiper. The windshield wiper.
Wait, what? Oh, erase all strokes. Okay. I just went back. Wait, I just hit that button. Wait, hold on, resume. There you go, I'm good. Bro, I'm so dope at this.
4 over square root of 5.
Diamonds on me, ice
They're
cream.
both perfect squares. So if I redo it and focus just on the numerator and the denominator individually, the square root of 16 is 4. The square root of 25 is 5. So it'd be 4/5. Okay? So it's nice when, so that is simplified. So we're done. 4/5.
We're done.
Huh? So the good question. So the square root of 16 is not the square root of 4. It's just 4. So it's no longer a radical anymore. So then we're done. So don't take it to a 2. Okay?
What if they're not perfect?
So what if they're not perfect? Good question, Zach. Hold on, let's get to when it's not
You know
perfect.
how much I dislike you.
Yes. So when they're not perfect, we do something that's called rationalizing the denominator. So when you're asked to rationalize a denominator, what's happening is you're transforming a quotient with a radical in the denominator
Probably not, dude.
into an expression with no radical in the denominator.
No. I think I got an Earl sweatshirt.
Okay. So, it's proper algebraic skills to never, ever, ever have a square root sign in your denominator of a fraction. Okay? So in order to get rid of it, you're going to be doing something that's called rationalizing a denominator. And this is what it looks like. So here I have 1 over the square root of 3. Right now I have a square root sign in my denominator. What do you think I could multiply the square root of 3 by to make it no longer be a square root sign?
2.
Not 3, the square root of 3. Think about our prime factorizations. We were looking for pairs because 3 times 3 would be 9. And what's the square root of 9? 3, right? So whenever you have something in the denominator that is a radical, this is what you're going to do. You're going to multiply, that's if we were solving, we're not solving. We're going to multiply whatever is in the denominator by itself. Okay? So the square root of 3 times the square root of 3 gets us the square root of 9, which is 3. I'll get there in a second, which is 3. Now, think about your identity property of multiplication. What number can I multiply any number by that won't change the number? 1, right? So isn't it true that anything divided by itself is 1?
Yep.
So for this to be a very fancily picked number 1, what I do to the bottom, I must also do to the top, right? Because isn't that the same thing as multiplying it by 1? So it means I'm not changing it, I'm just rearranging it so that it doesn't have a denominator in the radical. Yeah, you see that? So if I focus on my numerators, what's 1 times the square root of 3? The square root of 3, which just says the square root of 3. So now I rationalized the denominator.
Yeah.
What did you do there? Wait, how
So-
does square root of 3 over square root of 9? Square root of 3.
The square root of 3 divided by the square root of
How does
3,
that
or
help
sorry,
anything, though?
because now this is proper algebraic notation.
Like, how does that help anything?
So it's the way that you should be writing something. You should not have
But,
the
like,
square
it's
root in. It's just manipulating the number to look different. It's still the same number. Okay?
So basically, you put it on top and on the bottom.
So if we had 4 divided by the square root of 2,
2.
what should I multiply the numerator and the denominator both by? The square root of 2 on the top and on the bottom. What am I going to get in the denominator?
4.
The square root of 4, which is 2. What am I going to get in my numerator?
Square root of 2.
Well, times 4, so it would just be 4 square root 2,
8.
which is not 8. That's 4 times 2, not 4 times the square root of 2. The square root of 2 is some funky decimal that is
So it'd be like 4.
larger than 1 but less than 2. Now, think about this. If I had 4 square roots of 2, so if I physically made 4 square roots of 2, and I were to cut them in half, how many would there be? 2, right? Then I would only be left with 2 square roots of 2. So if I have 4 square root 2 cut in half, my final answer is going to be 2 square roots of 2. 4 divided by 2 is 2.
But wouldn't the square root of 2 have to also be divided by 2?
Nope. Think about if you had 4x divided by 2, what would it go to? It would go to 2x. It wouldn't go to 2 half an x. Huh? I didn't hear your question. No, it's not. Let's try another one. 6 over the square root of 7.
Let me try it.
Oh,
Can I try
God,
it?
I get it now. But, like, I hate it.
Can I try it?
Tell me how to do it.
Alright, so you're going to do square root of 7 on both.
Yeah.
And then you're going to go,
So what's
6.
gonna-
You're going to write 6 square roots of 7.
And what's on the bottom?
49.
Which is
49 49.
Square root of 49, which is...
7. 49.
7.
Can I simplify 6 divided by 7?
No.
No, so now I'm done.
That's it?
That's it.
That's great.
I like
That's
6,
my
7
answer.
squared, 7. 6 times squared is 7 over 7.
Huh? Not that hard. Okay. What if you had a square root in the numerator?
Oh. No.
Do the same process. So what are we going to multiply top and bottom by?
And square root of 3.
The square root of 3. Good. What's going to be in my denominator?
Square
Just a 3, right? Because the square root of 9 is 3. Now, because I have a square root of 5 times the square root of 3, it's going to combine to make the square root of
And then
15.
you're done, right?
Then I am done.
Number up front.
Right. I don't have a number out front. Technically, it's 1. 1/3 doesn't reduce,
I thought
right?
it was 5 to the third, or on the top you put 5, 3.
That was if that didn't have a radical sign.
Yeah, man, come on now.
So now it's 5 times 3.
Yep, it has a radical. Okay? All right, so now are we able to put all of this to section 9.7? Yes, let's do it. Do it. Do it. Here we go. Alrighty. Solving quadratics using square roots. You are now professionals at simplifying square roots.
I just noticed I took all these notes on the back of the challenge.
We're just turn in the challenge paper so you can get credit for it.
Sorry, pal. You shouldn't have my phone.
Do it quick. All right.
When do math fields this used?
When anything that goes up and comes back down is a quadratic function.
Like when?
So rockets, things that swing. So a lot of engineering stuff is quadratic. Yeah, so we're going to be using that while doing this. Okay?
So that wasn't 9/7 that we were doing?
No, you're going to be using those skills within this section.
Wait, so it's going to get harder?
No. Do you know how to solve an equation like x plus 1 equals 5?
Isn't this one a no?
Yeah, these are quadratics are parabolas. Yeah. We'll be graphing those in 2 weeks.
Wait,
All right.
that's a part of this challenge.
So, if you think about your quadratic equations, the degree of the x is what? Quadratic. 2, right? So all of our equations that we are solving for will most likely have an x squared in it. You know how to solve linear equations just by doing either a one-step or a two-step equation or a multi-step equation. But now what's going to happen is we're going to turn our equation into an x squared. Now let's think about this. If my equation was x squared equals 49, right away you guys said 7. Because we know that 7 squared is 49. But isn't there another number that you can square that gets you to 49? Negative 7 squared is also 49, right? So when you're stuck with a degree of 2 in your equation, the inverse of squaring something is taking the square root of it. So if I had x squared, if I take the square root of it,
X.
it's just going to go to an x,
Yes.
right? What I do to the other side, or what I do to one side, I have to do to the other side. And our instinct is going to be the square root of 49 is 7. But it's going to be both positive and negative. Remember I showed you guys that symbol before? Okay, so plus or minus 7. If you want to write it out as positive 7, negative 7, feel free. Let me back this up with some more evidence. If I wanted to solve this equation by factoring and move that 49 over, what do we have? A difference of squares. What does that factor to? X plus 7, x minus 7. What would have been your solutions if that problem was on your quiz? 7 and negative 7. Okay? The more you complain, the hotter it's going to get. So
We
stop
solving
complaining.
quadratic for like zero property or like what are we doing?
So now we're ignoring the zero product property and just doing square roots.
Zero product.
Yeah, with solving by factoring. We're learning different methods.
So we're still learning zero product.
No, that was done in 9-6.
So are we still, we're not doing anything with equaling zero?
Well, all of these will equal 0 sometimes.
You just said
Depends.
we're not doing that.
Well, it could equal 0. I don't know. All right, here we have x squared equals negative 49. If I square root both of those, is there any way for me to possibly square a number and end up with a negative result?
No.
No. So whenever you end up with an x squared equaling a negative number,
Wrong.
we are going to say no real, because there's an imaginary solution, but you don't get to that until algebra 2. No real solution.
Like you use like imaginary solutions. Like what even does that mean?
So in math, you have to be able to explain everything. So if it's not real, then what is it? It's an imaginary.
Why would you have the equation if there's no answer?
Gosh, you guys are cranky today.
No, like this is
I'll write this one down.
You have to say this is in the
We're
way.
gonna give it to you.
Okay, 5x squared minus 180 equals 0.
Salmon's on the ice cream.
So you gotta add 180.
Now, if I was going to factor this, I would think about pulling out a GCF, which I could take out a 5, but then that still is going to leave me with x squared minus something, which might get a little bit complicated. So, when we're solving by square roots, solve it just like you would a linear equation. Ignore this x squared right now. If that was just an x, what would be the 2 steps you would take to solve for x? You would first plus 180 to both sides, and then you would divide by 5. So let's do those 2 steps. Add 180 to both sides. So now we get 5x squared equals 180. And then we would divide by 5. So that gets me 36. Okay, so now this looks like the original problem we started with, but instead of 36, it's 49. So to undo a square, you take the square root. But remember, this is quadratic, so you need 2 solutions. So it's plus or minus 6. Don't lose points on that.
Why can't you just say that?
Do you have to write plus one? Can you write like 6?
Yeah. You can do 6 and negative 6.
Like, why do we have to reverse the like x squared?
Because you're solving for x. Your final answer is going to be
Yeah,
x
but can't
equals
you,
something.
Well, you can't just say x equals 6 or negative 6.
It's
Like,
equal dick,
reverse it and do that thing.
If you can go right from there to that, then do that. I'm just showing all the steps.
Like the square root of 36 is 180.
No, it's not. You were correct in that statement. All right, put this one down. 3x squared minus 75 equals 0. See if you can solve this one on your own.
Just be on final.
Yes.
3x squared equals 75.
Please.
Yes, that is correct. Yeah. Yes, that is correct. Yes. Plus minus. And then you got it. Good. Good. Solve it by using square roots. Don't factor it. Yes.
Is it this?
Plus minus 5. Good.
Is it this?
So adding your 75, dividing out your 3 leaves you with x squared equals 25. Good. Plus or minus 5. Nice. Good.
No, I didn't get 5. How did you get 5?
Square root of 25 is 5.
Bro.
You forgot to square root the 25. Alrighty. How about this one?
Oh,
I know on the iPad.
no real thing.
X squared plus 10.
Resolution.
X squared equals 10.
X squared ends up equaling 0 when you subtract the 5.
Oh
You gotta do
my
x
God.
equals negative or positive
What's the
0.
square root of 0?
0.
Can you have a positive and a negative 0?
That's easy.
No, so it'd just be x equals 0. If you put positive, negative, I would laugh, giggle inside my head and say,
Come on now,
haha,
that's what
they
it'll
just
be,
said there's a
though.
positive and a negative 0. I won't take off points, but there is no positive, negative 0. 0 is 0. It's
So
neither
there's no
positive nor
or
negative.
0.
No, it's just 0. It's
So
nothing.
if you would times a negative number times 0.
All right, now let's bring in our new set of
There's no
skills.
positive 0 either. So what is it?
There's no
It's just
independent
0.
clauses.
There's
So
gotta be something.
What would you do
Exactly.
to... Okay, guys,
just be
please
nothing.
stay with me here. What would you do to get x squared by itself?
Questioning my existence now.
Okay, what's 24 divided by 3?
God.
Oh boy. Is that a perfect square? Okay, but we just learned a very fancy skill.
You done did it.
Let's simplify the square root of 8. Go ahead and see if you can simplify the square root of 8. Make your branches.
Isn't it just 2?
No, I don't want it.
2 square root.
2 square roots of 2.
2 times 2 times 2. X squared. Is it 2 squared?
2 times
X squared check mark equals.
Don't forget your plus or minus.
What is that?
Yeah, whoa, whoa. Would it be 4?
2 times, there's 3 2s.
Wait.
4 and 2. 2, 2, 2. 3
What
2s.
Oh. Wouldn't that be 4?
No, because you're left with 3 2s.
Yeah, and your box can
So
make
that
it 4.
goes to the square root of 4 times the
Yeah.
square root of 2. The square root of 4 is 2. And then
So
I'm
why
left
is
with
that two?
the square root of 4 is 2. Alright, so we get plus or minus 2 square root 2. Let's try another one.
I'm shot.
9x squared equals 25.
And minus.
Divide out your 9. What do you notice about your numerator and your denominator? They're both perfect squares, I heard Zach say.
Oh, I think I did it right. You're right.
Positive, negative 5 or 3.
Yes, positive negative 5 over 3 is correct.
I get 5 over 3.
Square root of 25 is 5.
And you can even guess.
Square root of 9 is 3. And if you say that one more time, I'm going to send you to the office and tell Miss Lynn that 10 million times. We good with that one? Okay, what about this one? See if you can do this one on your own.
Negative, positive, 1 over 6.
Josh, it's 9x equals.
Negative, positive, 1 over 6, right?
Yeah.
Be the square root of 1.
Whoa.
Square root of 1 is 1.
Hey, don't know.
Good.
Sometimes I have my moments.
Divide by that 36, Jackson. Good, good, good. 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 Huh?
Okay, I told you the answer.
So dividing out the 36 from both sides gets us x squared equals 1 over 36. Square rooting those gets you 1 over 6 plus or minus. Okay. Ooh. Let's write this one down. 15x squared equals 50. Divide out the 15. What does 50 over 15 reduce to? 10 thirds. Oh no. Are either of those perfect squares? Nope. Bummer.
Times it, bro. Times that.
So that means we have to do what to the denominator?
3.
Rationalize the denominator. What am I going to multiply it by? On the top and the bottom. Someone tell me what's in the denominator.
9.
Well, so that would go to 3, right? The square root of 9 is 3. What's, yeah, the square root of 30. Don't forget your plus or minus. That's your answer.
Weird. Wait, don't go to the next one.
I'm not sure how.
Wait, how'd you get, so you went 3 to 3 on the bottom, right?
Yeah,
Why'd you go 10 to 3 on the top?
because it was this reduced to 10/3. Then you're left with the square root of 10 times the square root of 3, which is the square root of 30.
We start the worksheet and see if we're doing it right. Just like,
What do you mean?
Yep.
Wait, no, 10 times 3. Do you do 10 times 3?
Huh? 10 times 3 and put it over, yeah, just
Put it
30.
over the denominator of
What would our answer have been if this was a negative 50?
Negative.
what's negative 50?
It would be
Can you-
nothing.
It would be what?
No.
No real
solution.
solutions. Good, good, good.
I said nothing first.
All right. Is that all I got for you? I think so. Let's see if you got your homework down.